we're going to start. So remember, this is your point estimate. This is your margin of error. So if you have, like 10 or proportions, so like 0.10 plus or minus 0.02, let's say. That is your margin of error. That's how much you would go each way from the center between like the boundaries of your confidence interval. So sometimes they start from that. And they say, okay, we need to get a margin of error of 3. If I know I need a margin of error of 3%, and I want to say 95% confidence level, how big does my sample have to be? So you can kind of work backwards. So what we're going to do is, this is the margin of error right here. We're going to set that equal to whatever percent they're giving us, and just do basically algebra to solve for it. So it's not too bad. It's probably like the most mathy thing we do in here, actually. That's not bad. So if I look at that first one, sometimes they'll give you p-hat, sometimes they won't, and we'll talk about what to do if they don't. So assume p-hat is 0.57. I want a 3% margin of error, so margin of error equals 0.03. You got to put it like in decimal version. Got a 95% confidence level. Find out how large of a sample I will need. So the margin of error is Z star times PQ over N. Like every time you go through that process, I have you point at that number after the plus minus and say margin of error. This is part of the reason why. I'm just trying to drive that home, that that's the formula that gives you margin of error. And we can find everything in there except for N, and like I said, we just do algebra from there. So how do I find Z star? Well, there's something before the 1.95 divided by 2, right? Inverse norm, 1.95 divided by 2. You want to round like as little as possible. So I try to do the whole thing in my calculator and leave the numbers there so it doesn't round, because you end up dividing by a tiny number. And when you divide by a tiny number, if it's like a little bit off, it changes your answer a lot. So I'm going to write down 1.96 here, but I'm going to do as much as possible. I'm going to just leave it there and work with it from there. I'm writing down the rounded version, but I don't really want to work with the rounded version. What's P? 0.57. What's Q? 0.43. N is what we want. So I don't know what that is yet. I'll leave you guys very much space here, I guess. And then the margin of error is 0.03. So my first step is I'm going to divide by 1.96. Sorry, 1.96. But in my calculator, I'm going to do it this way. So I'm going to do 0.03 divided by second answer. Do you guys know about that one? So if you hit second and then the negative sign, it says A and S, and it just takes your previous answer and slides it in that spot in the full version, not the rounded version. And then again, I'm going to write down what that says, but I'm not going to work with what I wrote down. I'm going to work with what's in the calculator, so it's not rounded. So what I've got now is, let's do this other part too. So 0.57 times 0.43 over N equals, and it's like this 0.0153. You with me? Mathematically, we okay here? It's an algebra class now. So I got to get the N out of the square root, right? So what's the next thing I would do? I'm going to square everything. So I'm going to have 0.57 times 0.43 over N equals, and then in my calculator, I'm just going to hit to the second. It's going to take my previous answer, like the whole stretched out version, not rounded, and it's going to square it. And it's tiny. You get this e to the negative 4, that's really common. You'll get like so it's such a small number that it's an exponential. And I can write it down over here, but that's not really the important part. So this would be 0.000234. because I wrote a point in the wrong spot. My bad. There's this new kind of math where there's like 2 decimals in every number. You don't know about that? Are you okay though?
Yeah, that was it.
Okay. So now, there's this like algebra trick. So you don't have to write this down, but if I had like 12 over x equals 4. What's x? 12 divided by what gives me 4? It's 3. So if you have this setup, where it's like a fraction and then not a fraction, you're allowed to just exchange those 2 numbers, because watch what would happen. Does that give me 3? So that's a little like cheat that you can use. So I'm going to use that cheat here. And I'm going to exchange those 2 numbers. And so what I'm going to do on my calculator, what I want is 0.57 times 0.43, and then divided by the number that's like stored in there right now, right? So, again, I'm not rounding ever. I want 0.57 times 0.43 in parentheses divided by second negative sign to get my A and S. So I'll take the previous version, and then hit enter. That's our number. So, another thing about this, which doesn't come up a ton, but it can, is I need at least that many people in my sample to get the margin of error small enough. So how many people do I actually have to ask? Because I can't ask 1046.15. So I have to ask 1047, right? I have to go up to the next person. So that was kind of a lot. I mean, there's algebra. It's not too bad, but there's also calculator stuff going on there. Can I answer any questions about that one? Yeah, for sure. Let's do number 3 together, and then I'll let you guys try the other ones. So right away, reading through number 3, what's missing? P hat. Sometimes they don't give you P hat, and that's a very real life situation. I don't know P hat. Like if I'm gonna start getting, like yesterday, you guys asked that yes no question. Do you really know what your P hat's gonna be? Might have a general idea, but you don't really know. So where would you choose that is the safest? Why 30? I'm just curious why.
Just kidding, that's from the other unit.
Oh, okay. So what proportion would you choose as the safest? I'm going to choose 0.5. Because what's the biggest error I could possibly make if I choose 0.5? If I'm asking a question like what percent of people do this, whatever, and I say 0.5, the most wrong I could ever be is 50%, right? Does that make sense? Like 0.5 to 1, like that difference. Well, let's say I guessed 0.8. How wrong could I actually be? I could be 0.8 wrong. So the safest guess you can make, if they don't tell you P hat, you use 0.5. Because right in the middle, it's just like a conservative estimate. And then I want a 90% confidence interval. How large a sample do I need? So Z star times PQ over N, 5% margin of error. So make sure you do 0.05 there and not 0.5. That's easy to screw up the percentage to decimal conversion. And then start plugging in. So inverse norm of 1.9 divided by 2. So I'm writing down 1.645, but more importantly, I'm storing it in my calculator. Times P is 0.5, so therefore Q is 0.5 over N. What's my next step? What do I type into my calculator next? 0.05 divided by answer, right? Second answer. So that's 0.03, but it's stored in my calculator as a more accurate version of that. So I took the 0.05, that was on the other side, right? I divided it by the 1.645, but I want to use the calculator stored version of it. Which one? The answer? You hit second and then the negative sign at the bottom. Alright. What will be next? Square everything. So over here I'll get 0.5 times 0.5, which that's just 0.25. Like you might just write that at this point, but you don't have to. And then in my calculator, I'm just going to hit squared. And I get this 0.000924. But again, it doesn't really matter what you write down. I'm just doing it to keep track of my work. So if you screwed up writing down the exponent, the scientific notation wrong, it wouldn't even really matter. As long as you're doing the stuff in your calculator. And then I'm going to use that flip-flop trick. So what I'm going to type into my calculator is 0.5 times 0.5 divided by answer. So I get 270.55. You guys agree? So then how many people do I need to actually ask? 271. That's like 270 in Mr. Packer. Questions on that process anywhere? Try number 2. How many got 271 for number 3? Okay, cool. So they did give you Piat this time, right? So make sure you use the one they gave you. If they don't, you use 0.5, but sometimes they give it to you. You get 1086.9. So it should be 107. Where are you confused?
I get confused after you do the Z star.
2.576.
Yeah, so I got that.
Okay.
It's like the third step.
So getting from this step to this one? Is that what you're saying from here to here? So I'm dividing by the 2.576, so I can get like the square root part alone.
You're
So
dividing the.
I'm really dividing by, yeah. But in my calculator, I'm doing 0.03 divided by A and S, you know. Raise your hand if you got 1807. So if you're good, go ahead and do 4 and 5. If you're not good, let me know so I can help you.
Okay, so when you divide the 0.03 by like 2.76
5,
or 5, 6,
yeah.
whatever that is,
So are you good from here to here though?
Now I am.
Okay. And then from here to here, what I did was square everything.
Okay.
So really, it's like squaring both sides. That should be enough. Square.
Oh, wait.
So when I square the square root, it just leaves it like with the normal stuff inside. And when I square this, I get that really small number. And again, in my calculator, what I'm doing is like a and s squared to get to that.
Now, see, I'm just trying to figure out the graded so I understand it for next.
Gotcha.
Because this, I got lost.
So,
It's like, I know you get from here, you have to divide this by this.
well, whatever it is.
That's end of this.
Right, but then down here you got. Oh, that's like your. Okay, so
That's
then,
what I'm trying to.
then you have like this square root thing equals 0.01.
Oh, that is. So then you should
Then what?
square root
Yes, no,
this.
no. You get rid of square roots. What's opposite of square root?
That's square root.
Well, square.
Yeah, that's.
So you square the square root here, these just go away. Like the square root and square cancel. So just 0.57 times 20. Square this. And that is going to make the square root cancel. Now, this is that. So I'm going to square this. So we're just going to go like, what's the like, here, but to the power of, or you can just square this. So that's what really was key.
This equals that, even though it's this. So when this squared do that?
Yeah. So that's what you're going to write right here. Well, the sheet has an equation, right? Well, but then it's this thing. That sounds right. I remember that one last year. I didn't do it yet, but
Oh, for 4. Oh, I'm sorry. I thought 4 was the last one.
I just didn't
Okay.
I apologize. That was very close.
okay. And then you're gonna use this like exchange property. Square plot these. That's coming. That's the step above it in the equation. We're working down. I think you're thinking this is way harder than it is.
I just don't know how to write it out, so I know what I'm doing in my head.
I think it might help if you did it like I'm trying to squeeze it in. So you just did it like straight out. So you can see like both sides. But we're not done. Now you gotta do it like that. So you're gonna do 0.57 times 0.14. And then divided by that cancel. So let me do these two. You get 423 for number 4? Oh, no, sorry.
271. Same answer. They're not the same answer. They're the same answer.
271? It's the same answer for the next one.
No, 3.
No,
Oh, yeah, right.
even down to the decimal.
2401, number 5. So if you got those, great. take some time, use time to do any of those things. If you didn't get those, let me know it's not gonna help you. Oh, okay. But like you think your process was good?
Oh, yeah.
Okay.
It's still pretty long.
For 2 and 3, would they be not the same?
They're probably not the same. Like if you ask 70 different people your same question, you might get the same, but you might get something different. So it's like not necessarily. You know, like when you did that computer thing and there was bars, like they weren't always spot on. But they might be. They probably are. And then this is where it goes away overhead, right? Yeah, and remember it's a the scientific one, so. So you gotta go to the decimal 4 spots over, so it's gonna be 0.0005, yeah. It doesn't matter, because you're gonna do it in your calculator. Like that's the point. Is that we're not worried about rounding. So you're gonna. That's okay. It's still there. It's still there. Wait, close parentheses. You gotta put the first parentheses. Now divided by. Yeah. It's still not. So, here, watch me just tell you what you did. So I got this point on the floor, right? Okay, so inverse norm. Okay, then I point on the floor divided by that. But did you do divided by an answer, or did you use 1.64? I think you did 1.64. You always want to use the same answer, because if you round it, so the real answer is like 271. You got 268, which is like close, but I don't know if your choice, that might be nothing.
I know, that's why.
So that's, so now I'm here. So I'm square it, so it's
Because,
square. And then I'm doing the point 8. So I think you used that as because I noticed that here too, you were up at like 2, which is probably fine on the multiple choice because the answers are fine on the mark, but you just want to share. Does that help? So do the last one too. Peyton, are you good after you fix that?
yeah.
Okay.
She did say.
Any other questions on these? Definitely on the test. Definitely on the AP test. I mean, if you don't get it, you want to make sure you're okay. You guys get these? This new stuff? Okay. So why are you so surprised by this? Actually, you like those? You're actually doing that.
That's you need to like say like title or something.
This is your title. So that's like your thesis. But you don't need to put like the context of it. You're titling the process more than titling what's the model. Thanks.
chatted on it.